Number 76. We're given the function f of x is equal to negative 3x squared minus 24x plus 5. And we are asked to determine, does it have a maximum or a minimum value? What they're referring to is this equation. When we have this x squared, it's going to produce a parabola. So if we bothered to graph this, it's going to be one of these U-shaped curve. It's either going to open up or it's going to open down. If it opens up, this vertex, this bottom point, it's a minimum value. If it opens down, it's a maximum value. Well, that can be determined by the sign of this first coefficient. Since this thing is negative, the parabola will open in a downward direction and the vertex will be a maximum. We can find that by a formula we've used before. X equals negative b divided by 2a. This gives you the axis of symmetry, but it also gives you the x value of the vertex. Alright, so in this case, b, this value b is negative 24. It's the coefficient of the x term. And we're negative, and it says negative that, so it's a negative 24. That's just a positive 24. And 2a, a is the coefficient of the x squared term. In this case, negative 3. Negative 24 is a positive 24. 2 times negative 3 is a negative 6. 24 divided by negative 6 will be a negative 4. That's the x value of the axis of symmetry. The x value is a negative 24. So we're going to take that x value and substitute it in and find the y value. So substituting negative 4 for x, f of negative 4, negative 3 times negative 4 squared minus 24 times negative 4 plus 5. From this line here to this line, we have just substituted negative 4. Every place that we see an x, we have substituted negative 4. What we're trying to find is what is the pairing value with negative 4. When negative 4 is x, what is that? Y. That will be this value will be the maximum function value. Alright, so negative 4 squared is 16 times negative 3 is negative 48. That is a plus 96 plus 5. 101 minus 48, this looks like 53 to me. Again, I'm not using a calculator, so you want to check this out. F of negative 4 is 53. This 53, the maximum value is 53. Number 80. We want to know, is f of x equal 4x odd or even? Odd or even. To figure out if it's odd or even, substitute negative x in place of x. So I'm substituting negative x in place of x in both spots. A function will be even if f of negative x is equal to f of x. A function will be odd if f of negative x is equal to negative f of x. Graphically, an even function is one that is symmetric about the x-axis. For example, an example of an even function is f of x equal x squared. If we graph this, you get this parabola, and if you flipped it about this with the y-axis, it would be the same. That's an even function. An example of an odd function is f of x is equal to x. And you can kind of see where the name comes from. This is to the first power, odd power. This is to the second power and even. That's a little bit of an oversimplification, but there's the ideal. This f of x equal x, this is this diagonal line with slope of 1. Here, if you rotated it 180 degrees, it would be symmetric. Imagine spinning this paper upside down. This thing would be the same. So again, all you got to do is just substitute in place of x, substitute a negative x, and then evaluate your function. When we do this, well, 4 times negative x is a negative 4x. So what we see here is f of negative x is equal to negative 4x. Well, this part here, f of x, 4x, that is f of x. So I can make that substitution. Where it says 4x, let me substitute what we know 4x to be, which is f of x. So this becomes negative f of x. So what we see is f of negative x is equal to negative f of x. This is our definition of odd. So is it odd or even? Number 80 is odd. Clarify this one. 76. It is a maximum value, and that value is 53. The point is negative 4, 53. That is the vertex. Right. '83. We're given f of x is equal to 1/4 times x minus 2 quantity squared, and we're seeking the vertex and the axis of symmetry. Well, this form of the equation is called vertex form. We say if it's f of x is equal to a times x minus h quantity squared plus k. This h and k value is the vertex. H comma k is the vertex. And the axis of symmetry, since again, when we have our parabola, if you have some parabola, this little blue line is the axis of symmetry. It passes through the vertex. So they're going to have the axis of symmetry and the vertex will have something in common, this x value. Okay, so whatever this value is here will be the axis of symmetry. Alright, in our case you can clearly see that h is 2. This subtraction here, you can think of this as being the opposite. In this case we got minus 2, so h is 2. Really you can just simply see that h has to be 2. So h is 2. This is the x value of the vertex, and it is the axis of symmetry. Since h is 2, the axis of symmetry, this vertical line, is x equal to the vertex is hk, h comma k, and again that h value is 2. This k value, you can see k is the constant added out here. There's not one. Since there's not one out there, that k value is 0. Alright. So number 83. 83. The axis of symmetry is x equal 2. The vertex is the point to 0. Number 88. We're asked to graph f of x is equal to 2 parentheses x minus 3 quantity squared, and compare, graph and compare to our parent function f of x is equal to x squared. Alright, so we begin by graphing our parent function. This is the parabola f of x is equal to x squared. Now we want to graph this new one. Instead of calling the f, just to call it something different, I'm going to call it g of x. Alright, and let's go ahead and mark, we'll make it red. So our new function g of x is this thing. Alright, what's this going to look like? Well, this minus 3 shifts it right 3 units. So moving right 3 units, 1, 2, 3. This is our new vertex. The new vertex will be at 3, 0. And you can think of that as our h and k. Again, this h value 3 and the k value 0. That's the new vertex. This 2 is a vertical stretch. It's going to be skinnier than this one. So here's what your new graph. You could plot some points to get it exactly, but it's skinnier. It's a vertical stretch because of this 2 multiplier, and it's been shifted to the right 3 because of that minus 3. Again, I suggest use a graphing calculator to take a look. And the one I showed in the other video, if you don't have one, Desmos, go to Desmos and just type that in. Great online calculator. Alright.